Aravindan sir.
Ma'am, நான் share பண்ணிட்டேன். You can start the program now, ma'am.
Okay, sir. Good evening to one and all present here with warm greetings from SRM Institute of Science and Technology, Ramapuram campus. It gives me an immense pleasure to give a warm welcome on behalf of Department of ECE for Futuretronics 21, a webinar on career opportunities in electronics, computer, and communication engineering. I extend my warm welcome to Dean of our SRM Ramapuram campus, Dr. M. Muralikrishnan sir, and also I welcome Dr. Panikumar Polasi, Professor and Head of EC Department, SRM Ramapuram. My hearty welcome goes to students from various schools and diploma students from various polytechnic colleges. Now I introduce speaker of this webinar, V. Arun Kumar, Manager, Software Development, Pearson India Education Services Private Limited. He has 10 years of experience in software development and architecture. He has previously worked in IBM and Wipro, and also he has worked on different software products in telecommunication, banking, and education sectors. And also he has presented a paper in various international conferences. I welcome you, sir. I hand over to Mr. V. Arun Kumar. Arun Kumar, sir. Arun Kumar, sir, it's audible?
Yes, madam. It's audible.
Okay, sir. So you can share your PPT.
Sure.
Yes, sir.
Good evening, all. So today we are going to talk about the role of cloud computing in electronics. So when we are talking about cloud computing, as most of the audience are school students and college students, I'm going to give a little overview about what is cloud computing, what is software, and like what is the importance of it. So basically, we need to understand what is cloud computing before getting in depth into it. So I'm going to show you a timepiece. Is it visible? So this was used by my father when he was doing his college studies in 1976. And then wake up early as 5:30 in the morning. And then, so you have to do your regular
Guys, due to network issue, he got disconnected. Okay, within 1 minute he will join.
Sorry, there was a technical issue. Hope I'm back now. Am I audible?
Yes, sir, you are audible, sir.
Sure, all good. So again, back to this timepiece. So in my college days, typically we don't use this alarm. So and it was created in 1976, right? So my roommate, his name is SR. Okay, so he used to wake up at 5:30 and even 5:30, even before that. Okay, so he wanted to use it and then he asked me, "Shall I make use of it?" I said, "Okay, go ahead." So he used to set up alarm every day and for 5:30. Okay. Another guy who is 8 o'clock guy. Okay. And 5:30 in the morning when RR is asleep, this SR's timepiece will ring nicely. Okay. And so at 5:30 when you are asleep, when you are hearing this kind of sound, what happens? An automation gets triggered. RR taps SR and say, hey, can you please shut it off? And then he will close it. And that is how we were, the college life near 2004, the college life was like that. But what happens today, if you see, my nephew, he wanted to set up an alarm. Just before going to bed, he says, hey, Google, can you set up an alarm at 5:30 in the morning? And Google happily says, yes, done. And then it is waking him up sharply at 5:30 with a nice music. Okay. So this is the change we are seeing in 10 to 15 years. We are able to see a dramatic transformation. If you see how the voice command, whatever the voice we are saying, we are talking, this is getting transformed and then how the action is being performed. Yeah, and Google, the connected devices, right? So Google is able to understand your voice. It's able to recognize who is talking. If somebody else is talking, it says, no, it's not you. It does. So for everyone's voice, whoever we are pre-configuring, it acts according to the respective person. It's able to understand who is talking. So that much of intelligence is brought inside these devices. When you say order me this food, when you say book a cab for me in the morning, order me a product, and so it says your order has been shipped. Shipped, if you see the term shipped, right? So today, shipped is not the literal meaning. When you say order groceries and you're getting a message saying your groceries have been shipped already. Okay. So if you take the literal meaning, are we receiving the groceries and vegetables? Is it being transported in the ship? No, we cannot take the literal meaning for shipping, right? Though they say your product have been shipped, the shipping has a different meaning today. But there was a time when you wanted to order a hard disk, it was really being shipped, literally. So if you wanted to bring a hard disk from a country, they have to transport it through the ship. Just imagine how huge the hardware would be. That is how it was working some years back. When I was working in IBM near 2011, I was working for a leader in the telecommunication sector. So they are the leader in the telecommunication sector in US. So when I was working for the telecommunication provider, we were doing some automation. It was kind of a cloud creation, custom cloud creation. In 2011 itself, we were creating a software for it. During those times, when they are giving the infrastructure for us to develop this software, I used to wonder, so how much ever space they are giving for you to do the development, it gets filled so often, very frequently. So we will be getting an email saying, hello so and so, your space got filled up, you need to clear your logs, you have to clear your directories so you can continue your development. Our work gets stopped there. We need to find out what are the junk files available, where and all we need to go and clean. So in so many different places, you will have large data getting stored. We need to find them out, and then we need to create like a kind of a, we need to delete all those files so you get some free space. And we would be talking, this is a company who is a global leader in the telecommunication sector, and we are creating the cloud infra for everyone. And why don't we get a little more space? So we don't need to do this exercise regularly. We need to clean up. Just like if your mobile space gets filled up, we need to clean up before installing any other application or before performing any action, right? Just like that, the software development servers as well, they works just like that. But when we were talking this way, that means we did not realize what is the pain behind giving you little more space. What happens exactly? So if they need to give you 1 GB of data extra, just we need to think what are the things happening behind the scenes. In those days, if you need to get some more space, today, if you want to create some more space for your computer, what you do? You're going to order a hard disk and then attach it to your computer if the slot is available, correct? This is the usual case. In case of servers, what happens is you need to find out who is the manufacturer of that server. You need to write a letter to that manufacturer stating we need to increase the hard disk space because this is not sufficient for us to do our development or our usual activities. So can you bring us one more hard disk? We wanted to install that, or remove this existing hard disk and then replace it with a higher capacity. Because it is not as simple as how we can replace the hard disk in our desktop computers, which is in home, or the laptop computers. This is the manufacturer of the server only can decide what can be done on the system. The very first problem they will have is, first of all, you need to have one more slot available to install one more memory device. If you don't have slot, there is no option. You have to remove the existing device and then replace it with a higher capacity one. Suppose if you have 100 GB, you want to increase it to 200 GB, you need to remove this device, and then we don't know what they will be doing it. They have to discard it or reuse somewhere else, and then they need to purchase a 200 GB one to replace it in the available slot. This is a major trouble they were facing, right? And once the vendor confirms, yes, everything is available, suits the needs of your server, yeah, we are ready to give you a hard disk, they will acknowledge your letter back saying, yeah, we accept your order, and then we will be shipping your order very soon. After that, they will be sending the hard disk to you. And just because they are sending the hard disk, you cannot open the server and do whatever you wanted. You need to wait for the installation engineer from the same manufacturer to arrive at your server space. They will come, They will only open the server, they have to install the hardware, and then they will close and go. This is the process. For this, it typically takes minimum of 1 month just to increase your hardware space. And for that, the charges, if you see, it will be huge. We can't imagine for this much of hardware, why do they charge so much? Because they own the server. So we need to, we can't go outside. There is no option of going outside. Okay. This is how we were doing the development, and this is how the servers were maintained before moving into the cloud computing. Hope all understood what are the pain points behind, like why, what are the factors which are moving us towards the cloud computing. So these are the problems we were facing. Now, let us talk about in 2014, most of us might have heard about the Big Billion Day sales from a famous e-commerce vendor. Everyone should be aware of it, right? So most of us would have heard about that. It was a huge thing in the history. They have done a sales of around $100 million in 10 hours. It was so huge sales done in the e-commerce space in India. So it was looking like a huge success for that e-commerce vendor, but actually it was not meeting their expectations. Even during the time, we used to order some devices, it was some crazy deals, like for 1 rupee they will give you a hard disk. For 1 rupee, they will give you a pen drive. So many got nice mobile phones for 1 rupee. So there were a lot of crazy deals. And this e-commerce company, they wanted to increase their infrastructure before 1.5 months before the sale day. The sale day is just before 1.5 months. They have deployed thousands of engineers to upscale their infrastructure to 25 times. Suppose, think like you have a shop, you are going to sell some goods today. Your shop can accommodate 100 people at a time, but suddenly you are going to announce a big offer and so much of crowd is going to come. And what this e-commerce vendor is predicting is they are going to get 25 times of the load of the usual traffic. That means today, if 100 means, they are predicting 2,500 customers will come to my shop if I'm going to announce this offer. But that went false. That was very less number in terms of the real-time traffic. So the typical, we know our people, right? When you say 1 rupee offer, everyone goes in the crowd. So whatever the calculations they did, whatever the preparations they made, everything went to a halt. So what happened exactly was all the servers were crashing. So around 30% of people were seeing outage in their screen. Whenever you are ordering something in any e-commerce website, something like Amazon, Flipkart, I don't name anything, but these are the usual e-commerce apps we are using, right? So when you are using it, if you suddenly see a 500 error message, or if you see something getting crashing and you are not able to place your order, and that too, when you are getting a very good offer for 1 rupee, 4,000 rupees worth of hard disk you are getting, so who want to miss it? Everyone will be in a rush. So whatever the load they were predicting, it was over numbered and their servers were crashed. So what exactly went wrong? We will talk in detail about that, but why we are talking about this story is, it is going to give what was the problem statement. Now we understood what is the problem, right? Whenever the load is coming, suppose if there is a person in the market who says, I don't bother about how many people are coming, whether it is 25 times of my load, whether it is 100 times of my load, whether it is 1,000 times of my load, or just my load. Whenever my capacity is decreasing to the lowest or increasing to the highest, how many other people are coming, my shop can accommodate, right? So when a person is able to say this, his business will run without interruption, right? Without any interruption. Now, just to let us think about this. Suppose if this e-commerce vendor who I'm talking about, they have planned it 25 times, they have upgraded their server capacity. That means they have bought 4,500 servers just for this one day sales. So now we need to do a comparison between how much did we invest. The investment is not just the products alone. This is completely apart from the product. This is something like rent for your shop. You are renting a shop. So just like that, you are going to pay just for the servers. For one day, they have bought 4,500 servers. Even then, it was not at all enough. They were not able to meet the expectation. But even though they had a huge expectation, they were able to make $100 million, all those stories apart, but they were not able to meet what they intended to do. They were not able to flexibly scale up the server. After this sales day, the very next day, think what would have gone to the 4,500 newly bought servers, how much money they would have invested in that. They had to forcibly sell part of it, and then part of the infrastructure, they were using it within their company for different other infrastructure. Otherwise, for this sales, because the next day, 25 times whatever they made upscale, right, it will come to the normal traffic. So again, they had to go with the normal mode. So all these servers will be in vain. They had a huge capacity, they had huge investment, but they cannot give this offer for 365 days. They won't have this much of load. So they had to reduce their servers, and then they have to delegate whatever the investment they have done in terms of the server installation. This is where the cloud computing is coming into play. In a single line to say what is cloud computing, you don't need to own a server, but you can use the server. It is kind of a rented server. If you need to own a server, we need to understand what are the things we need to take care if I am going to own a server in my home. Okay, we cannot just like that keep the server in home, because the server need to be kept in a place which is suitable for the server. What are the factors? One is the weather need to be suitable. The temperature need to be maintained well for the server. That means it should be kept in AC, and you need to give a constant power supply. Suppose you are running a big business like Amazon or Flipkart, it need to be available 24/7. If the server goes down, you cannot access this application and the business will be in loss. So whatever the business we intend to do, we cannot perform it. So always the server should be up and running. For that, we need uninterrupted power supplies. It has to be available always. So they cannot just rely on one power supply, which we are getting from the government here, right? So it is not just enough for them. They have to rely on so many private power suppliers, and then they will have their own power generation. Power plant should be available. We need to have constant internet connectivity. So I have a very good internet connectivity, but just before starting this session today, we have seen an interruption, right? It was never expected. Just like that, if the internet is getting disconnected for a few seconds or minutes, it is a loss for the business. So we need to have uninterrupted internet connection reliably. That also need to be available. We need to ensure that. Moreover, like security. Security means I'm not going into the data security. How we are securing the data, how we are going to encrypt it. I'm not getting into that area. This is the physical security. When you have the server, it's not like someone can come and then switch it off. Someone can come and tamper the physical machines. So we need to have the physical securities available. So people should not be able to just enter into your server space. So these are the things we need to take care of it. I'll tell you a story. When I was working for this telecommunication provider in New Jersey, in America, there was a hurricane by then. So because of that, there was a lot of power interruption, and then the internet connectivity gone in the city in New Jersey. And guess what? We were enjoying one full week without any work, because we work in the remote system and the servers are located in New Jersey. And if flood in New Jersey means we will be happy, because we don't need to create any software. We don't need to do any type of work. We can't do anything if the servers are down. But it is a huge loss for company until all these interruptions are brought back. They have to bring the power supply back. They have to bring the internet connectivity back. All the water get clogged inside, need to drain out. So all these troubles are there. So till then, think about what will happen to the production server, which is serving your application. So this is a major concern, which is making the companies to move towards from the data center to the cloud computing. So cloud computing means, what is cloud? What is cloud computing? So it is not something which is available over the sky and we just store the data there and retrieve nothing. It is something similar to what I was talking till now. Just one difference is that the servers, we are not going to have it in our place. Instead of that, a third party is going to have enormous amount of servers and capacity available in their own premises. They will have so many servers and server spaces available. How much ever space you wanted to occupy, I want 10 CPUs. I want to increase to 20 CPUs. I want to increase to 50 CPUs. I will be able to scale up just on a click on my mouse. So it is not like what I said during the 2010-ish times. Now, in the cloud computing era, if you click your mouse in the cloud computing, you can execute simple scripts to bring the infra. You can make it upscale, you can downscale it. So this is called as auto scaling. So auto scaling means I'll give you some more explanation towards this terminology. Note it. So it is auto scaling. So we should be familiar about auto scaling. But when you move out, we need to understand. When you talk about, I know what is cloud computing, you should also know what is auto scaling, which is very, very essential. Auto scaling, you can say, scale up vertically or scale horizontally. Scale horizontally up, scale horizontally down, vertically up and vertically down. Let me give you some explanation on what does it mean to horizontally scale up or vertically scale up or down. Suppose, think like you have a server and then today the traffic is around 1,000 people who are using your application. Okay, so now your need for the server will be automatically computed. So there will be a script which is constantly monitoring all the CPUs for their usage. If at all the server traffic is going high, and if the CPU or memory shows high, it will automatically scale up. So during the production times, the scale up, we say it is horizontal scaling. That means we will have one unit server. The one unit server, you call it as 4 CPUs and then 2 GB of RAM. To put it simply, like we don't want to complex the terminologies. Just like that, think your desktop computer having 2 CPUs and then some 4 GB of RAM. Okay, so this is called as one unit. So according to the traffic, it will add up the number of instances or reduce the number of instances. So the instance, I mean the unit, right? So one unit server will be that. So according to the load, automatically it adds up the servers and then automatically it brings the servers down. So you are going to pay for the infrastructure for only whatever you were using till now. So we are not going to unnecessarily pay for these 4,500 or 5,000 servers and then just for one day, and after that you cannot use it. So we are not going into that mode, right? So that is why cloud computing is very, very essential. And nowadays, if you see the consumer electronics everywhere, wherever you turn, right? So the Internet of Things, IoT, and then COT. So these are growing up nicely. So earlier, when we talk about the electronic devices, we will hear some songs from the radio, and there is no connectivity, right? There is no internet connectivity. Washing machines are just washing machines, electrical, right? So today, every device is talking to the cloud. The switches in the switchboard, it is talking to the cloud. The AC is talking to the internet. The light, fan, your washing machine, mixie, grinder, whatever the home appliances we are using, including the motor, pumping motor, everything is talking to the internet. Why should these devices talk to internet? What do they achieve? This is what we call as the connected devices or connected infrastructure, right? So suppose I am going to some far town, and when I'm coming back, I need to ensure my tank is filled with water, my overhead tank is filled with water, and then my room is chill. So automatically, like there are intelligence brought, which will be sent from my mobile phone. So this guy is coming near this spot. So it is time to switch on the AC, and now we have to switch on the motor. And once the water is filled up, we will switch it off. So all this intelligence is brought through the internet and the servers. So the data is sent through the internet, and then it is stored in the servers. Just like me, who is having number of connected devices, I have in my home the connected lights. So when I say, can you turn on the light, it will be able to turn on the light. When you say turn it blue, the color will change, right? So this is a simple gadget, which is a connected device. And then when you say, can you play a song, the light can play the song. So there is a device like that which has inbuilt Wi-Fi connection, and then it is connected to the internet. Now, just think how many connected devices are there. So there is a survey which says 2 billion connected, 2 billion, let me confirm this number. So these many connected devices are available today, and it is rapidly growing up. When these many devices are connected to the internet and going to store the data, we need to have that much of capacity to be available, right? So everyone is storing the data. Like I was booking for a tour last year during August. So it's not last year, it was 1 year before. Last year we were in lockdown, right? So it was for a 7 days tour I was booking to Ooty. When I booked my travels, automatically, like when whatever I'm searching in my Facebook or Google, I was getting some advertisements. Are you going to Ooty? Use our travels to roam around Ooty. We have this package, that package, and all. And then I'm getting an advertisement says, do you want to book a hotel in Ooty? Try this. So they're giving an advertisement there. And then they say, do you want to visit our resort? So all these, and then for hotels also, restaurants also, all these messages we are getting, I was scared. So how do all these people getting to know that I am going to Ooty and I am going to stay there for 7 days? And one more guy is asking, have you booked your return trip? So this much data is available somewhere. It is getting stored. It is not just my data. Everyone's data is getting stored in a place, right? So this data is being utilized by so many people, and they are doing their own business, including the thieves. If a thief is getting to know that Arun is going to Ooty for 7 days, and if he is breaking my house, just think what happens. This is a negative part of our privacy and data being shared over internet. So we need to, when there are a lot of advantages, we need to see the other side of it, the negatives that also. So that summarizes the need of cloud computing today about the connected electronic devices, which is making the life today, and then which is moving towards the tomorrow. So the IoT space is still growing up, which is not matured yet. So the electronic devices, if you see, they are not staying just like the simple idle electronic devices in home, but they are talking to the world. So earlier we used to just to receive the signals for in some of the devices like television or radio. But today, every device in our home is able to talk to the outside world. If I say, hey Google, where is my key? Where is my bike key? It rings. There is a small tag which is getting sold, and then that is also a connected device. So it's a keychain. Okay. So this keychain you can attach to your keys, and then we used to forget the bike keys, right? I'm not sure about others, but myself. So I have got this device, and then it's not so costly, right? So it will be able to talk to internet. When you say, where is my bike key? You don't need to search for your bike key. Your bike key says, hey, I'm here. Come here and take me. When the detergent in your washing machine is low, we don't need to take care of it. It automatically triggers an order to the wherever we have connected, right? So whatever the e-commerce application we have connected, it will be able to order there. And even there are more applications like this which can even do the price comparison and then order the cheapest one for you automatically. Even you, without knowing that the surf in your washing machine is getting over, the next day if the delivery boy is standing outside and say, hello sir, your washing machine is running out of detergent, can you go and fill it? Then only we are getting to know, yeah, we are running out of the detergent. That is how today's world is working. So every device in our home is talking to the internet, and all data is getting stored. And this is like the world is going towards the cloud computing. So now I'm going to quickly show few slides and then going to wind up the session. Okay, so I'm going to just give you some little terminologies about the cloud computing. I don't want to bore so much using the PowerPoint slide. I'm sharing my screen. Madam, I'm not able to share my screen. Probably you need to make me as a presenter.
Okay, sir. I'll make you as a co-host.
Sure.
So it is present now.
Okay. Yes, I'm able to. Okay. So there are so many players in the market. When we are talking about cloud computing, whoever giving the cloud computing servers or the cloud computing services, there are so many different players in the market. Now, what is cloud computing? Yeah. So cloud computing is the delivery of computing services, which includes the servers, the storage, database, networking, software analytics, and intelligence over the internet. So this is what called as the cloud. So we know what is the cloud now, right? And using the cloud computing, we can easily scale up. And then this picture shows up the different services offered by the cloud computing. It's just this is the types of cloud computing. So I'll quickly show what it is. It is public cloud, private cloud, and hybrid cloud. Public cloud means a third party who is having their own servers available into their infrastructure, and then through internet they are going to offer the server capacity, and we are going to make use of it. And this is private cloud. Private cloud is used within the single business or organization. So if company initially the Amazon Web Services also started as a private cloud only. So they were using their infrastructure within their company. Initially, they were not offering the cloud services outside. How many hour servers they had? They have built the cloud only to be used within the Amazon. So that type of cloud is called as a private cloud. So in this way, you will still need to have the data center. That means your own building, your own servers, and then all this infra, we have to own it from the business. But public cloud means we are owning and then we are giving it as an offering for the outsiders. Hybrid cloud means it is combining the public cloud and then the private cloud. So it is bound by the technology. And what are the types of cloud services being offered? We say IaaS, which is infrastructure as a cloud, and then platform as a cloud, as a service, and then serverless and software as a service. I'll quickly give some examples about this. We'll start with software as a service, as everyone should be aware of this. For example, we can say Microsoft Office softwares like Office 365 is there, right? So the Excel sheet which we are able to open in the browser and edit today. Now, if you think about how we were doing this earlier days, we need to install the Excel software into our own machine, and then we will be able to use the Excel. But today, when the same Excel software is offered as a SaaS model, they are able to deliver it through the web browser. So that is the SaaS one. So that means how much ever we are using, accordingly, according to the license, we are going to pay. So that is a type of cloud service. That is software delivered through your browser as a service. And then we go to the infrastructure as a service. This means whatever we have been talking now is mostly on the infrastructure as a service. Like I need a computing capacity, or I need a storage, which is hosted by someone and offered as a service. This infra is provided as a service. That is the IaaS. And then this is platform as a service. The platform as a service is the entire package is given to the people, including all the networking, and then your capacity, storage capacity, compute capacity, everything as a pack is given, and it is ready for development and testing. So the entire platform will be given. So that is called as the PaaS. And then the serverless. This is one more emerging buzzword today. So today we are talking about, I don't need to own a server, but I'm going to hire a server. But the serverless technology is saying you will be able to host an application even without a server. You don't even need to rent it. So how does it work? So I will this is instead of we are going to hire a server, or we are going to own a server on a full time. This serverless is still runs on a server, but partly it runs on a server. How does it work? Whenever you are making a request, just for serving that request alone, this server gets executed, and for that few seconds which it is getting executed, it will be billed only for that duration, how much ever we are using. So it is not like you are hiring my server for 1 hour and all. It is nothing like that. If you are executing for 5 seconds, you will be billed only for the 5 seconds. So cost wise also, the cloud is much more efficient. So that is what a platform as a service we have talked. Serverless computing. So serverless computing is again overlapping with the PaaS model, and software as a service, which is delivering the software application over the internet on demand, and then on a subscription basis to your browser. Now we will see the comparison of different cloud providers. If you see, this is the Gartner's triangle. So So here, if you see, AWS, Amazon Web Services is in the top in the leader. So if you see in this graph, this is on the completeness of vision. How much ever I have completed my vision. So that is the completeness. So if you see here in the horizontal also, and as well in the vertical side, ability to execute. Who is leading the market is Amazon Web Services. And then next to Amazon Web Services, Microsoft is there, Azure, and then Google is there. These three are in the leader part. And then in the challenges, Gartner did not provide anything. And then in the niche players, if you see Alibaba Cloud, Oracle, IBM, and Tencent Cloud, all these are coming under the niche players, and visionaries, they didn't give anything. So this is the market analysis as of today. So who is leading the market is still Amazon Web Services, because the cloud services they have started, and then they are still leading the market, and others are well below the Amazon Web Services, because all other companies we are seeing here, where they have started the cloud services off late, and still they are trying to compete with Amazon Web Services, who is the global leader today. Yeah, so we have talked about the e-commerce, right? So 4,500 servers permanently they have added to the compute capacity, and they have done a so huge investment, and then 500 engineers were working throughout the day of sale just to manage all this trouble faced by the 30% of the users. And what the chief technology officer said was the statement which I have given at last. So what he said, it was our first time. We had no prior experience. All we had to look up to was our previous experience of flash sale of mobile handsets. So during that time, they will be selling the flash sale of mobile handsets they will be doing. So for 40 minutes or 30 minutes, they will be selling a mobile phone. And during that time, so much of people will be in queue. So they imagined the queue is going to be just like that. And they have even planned it much higher than that. Still, it did not meet. This is a case study for us. Now, what were the reasons for failure is, one is underestimated web traffic. So that was one reason. And then the scalability. This is one important factor. So they were not able to automatically scale up according to the traffic. And the third one is the DNS failure to share the load. Maybe it is too technical terminology for others to understand. So like DNS will be like a kind of, it will be sharing the load. So when the DNS is failing, we cannot share the load. And then the load balancer itself become a failover single point of failure. So what happens is the load balancer in a cloud system, what it does is, if you have 10 different server capacity, we will be balancing the load. Whatever the load is coming, I won't continuously load into single server. If I am having 100 servers, I will have different algorithms on how I should distribute the load to the servers. Accordingly, the load balancer works and then distributes the load. But if the load balancer itself failing, what will happen? It cannot serve the load at all. That was one more reason for the failure. And some hackers launched massive DDoS attack. So this is denial of service, DDoS. What they will do is, they will introduce like some traffic, artificial traffic. They don't need to hack into your computer. They don't need to hack into your server and steal the data. Nothing. If you are opening up a website, if they are creating something like in village side, people will say there is a person who is spending from his own pocket to disturb others. Just like that, there is some Tamil proverbs over that. Okay, just like that, there are some hackers who will spend money or you can think these people are enemy for this e-commerce vendor. So what these people might do is they will artificially create the load into your server just by using your application. They will mark up some 10,000 users using their own infrastructure, and then they will automate it as if these people are real customers. What will happen if you are going to have only 5,000 real customers going to access your website, but these people will deploy 10,000 mock attempts? So what will happen? Your server will be automatically loaded, and the real 5,000 customers will be frustrated. They will say, what, I tried to order something in this website and it was not at all working for me. I will never go back there. It had a lot of technical issues, all this, right? If we are going to use an application which is not working, it will create a huge business impact. So that is the part from some hackers as well from some of the enemies for that e-commerce vendor. So these were some analysis. Hope we have discussed some points around what are the factors which leads us towards cloud computing, and then the essence of cloud computing, and then how we are moving towards the future. So yeah.